Okay, so the tunnel of transmogrification, here's the notion, here's how it works. I have no idea whether am I on camera? I am. Okay, here's the notion of how it works, right? Is that two objects, matter is made of, hoping you say atoms pretty quickly. There we go. So matter is made of atoms, and atoms are mostly, well, by mass they are the nucleus, right? And by volume they are mostly space. Okay, so if we had an atom the size of the Rose Garden Arena, right, the nucleus would be like a golf ball at the center, yeah, 100,000 times smaller than the atom itself, right? Probably even smaller than that, like a grape or something like that, right? And so in theory, two objects made of atoms should be able to pass right through each other, right? Kind of a thing, right? Okay, is the notion, and because all of those electrons are just sort of, you know, running around the outside of the Rose Garden Arena, they're very small, right? The nuclei, the odds that two nuclei would actually get close to each other are very, very small, right? And so these things should be able to pass right through each other. And the thing that prevents this is, of course, something called the Pauli exclusion principle, which states that electrons cannot occupy the same quantum state, right? So even though the electrons are not everywhere at once, they are, in effect, like a yappy dog in a yard behind a picket fence, right? They're like, yip, 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 right? Even though they're not everywhere in the yard, they effectively prevent you from going in that yard, yes? Yeah? Right? Another analogy is that it's like the blades of a fan, right? Only that's not as fun as the yappy dog, right? You know, the blades aren't everywhere, but you can't put your finger in the space occupied by their trajectory, yes? Okay? So, I'm sitting in my inventing shed, I'm thinking about this, right? And I start doing a little work with the lepton numbers, right? Because electrons are leptons, right? And I start to do a Bose matrix inversion, right? Talking about their tachyon states. Yeah. And what I do is I actually portray them on the imaginary plane, right? And I run those numbers out on the imaginary plane, and I realize that the wave function actually collapses on a possible solution that if we only get time to run backwards, right, would allow these things to pass right through each other, right? Okay. Now, my limitations, and this is what you're seeing here, is it's my transmogrifier. Okay. The story only gets better, you know.
No, it's better this year.
Yeah. Okay. This is my transmogrifier, which will allow objects to go right through each other. Now, the one little problem that I've got is that the objects have to be actually identical, that pass through each other, right? Because I don't have the tachyon containment, right? I've got about 3 watts or so of tachyon containment, and you would need, I've calculated, about 300 megawatts, right, to actually get dissimilar objects. So eventually I'm going to get different objects to pass through each other.
Hello.
Qu'est-ce que vous cherchez? A Phillips head screwdriver. I've got a Phillips head screwdriver. Whom do you represent? More. All right. I just want to know where to go find my tool. Here you go. Is this the right size Phillips head? Indeed, it's not. Okay. There are sizes. I do have that size. Et voila. I think that should work. Try it. Does that work? Yeah. There you go. All right. Where were we? Okay. Different objects. So for now, what I have to do is I have to use these carts. Okay. I have to use these carts as the objects that are going to pass right through each other. Now I know what you're thinking. You're thinking, if they're identical, you're probably thinking, why am I so smart? Right? And why am I still teaching here? Okay, but beyond that, you're probably thinking we should probably mark the carts A and B so we're sure that they pass through each other. But if we mark them, of course, they're not identical, right? Yeah. Okay. So what I'm going to do, though, and just so because you guys are like thinking I'm like tricking you or something like that, right? So what I'm going to do is I'm going to send them into the tunnel with different velocities. Right? And that way we'll know that when the slow one, you know, and all this stuff, and the fast one, we can keep track of them that way. Okay? So, all right. Let me just fire this baby up. Okay. So I'm going to send, this is the slow guy coming into the tunnel like that. Okay, and I'm going to send the fast guy through. Oops. There you go. Fast guy goes on through. Slow guy goes through like that. Let's send the slow guy into the tunnel. slow guy coming into the tunnel. Here, we'll send this guy, fast guy, through. Okay, fast guy goes through as a slow guy coming out. That slow guy coming out, they're going right through each other. Okay, here's my favorite application of the transmogrifier, right? You get, like, sports cars would have a transmogrify button. So instead of passing somebody, you just pass through them, right? So like you're going into a tunnel, right? Slow car going into the tunnel, right? Fast car is like meep meep, goes right on through. Slow guy's like tooling along, right? Yeah. It's like, that's me driving down the freeway. Here's Mr. Dinza. Right? There it goes. There it goes. You're coming out. There we go. Okay. I'm gonna come even with you guys. Okay. This is just a false box. I just stuck like stuff on top there to make it look all technical and stuff, right? But the solution here is actually a simple one. If the objects have the same mass, then before and after the collision, what they do is they just trade velocities. Think about this. This really works. Like, for example, hit a billiard ball that's sitting still, dead on, with no topspin, et cetera, right? The hitting ball stops, the other ball keeps going straight, yes? We know this solution, don't we? Yeah. If we play billiards, right? So that works, doesn't it? So we've got one moving and one not moving, and now we've got one moving and one not moving. Isn't the energy and the momentum the same before and after? Right? Or how about this? I just love that. They just trade velocities. Isn't that great? That's what was really going on. I just made that other stuff up because it's fun to, pull the wool over the eyes, as it were. Isn't that crazy? I think that deserves a little. Okay, I think we need to do rubber bullets. All right. I need like a cameraman. There we go. Mr. Dinza, like. I don't. Yeah, you do. Okay, so you probably hear the explosions, and you're like, I better check on what Murray's doing.
Whenever I hear the explosions, I go jumping under my desk, suffering from PTSD. Cowering, like myself.
Apparently, Mr. Thompson doesn't like the Canon. The Canon is. Do I have sound? I do have sound. The Canon bothers him because it goes off and it's loud and.
It is loud.
Yeah.
And it reverberates through his classroom in my office.
Yeah. And I'm supposed to walk through the main office.
You used to do that.
I do still.
Do you?
I still should. We had a parent who was upset after 9/11. We set that thing off in the hall, and they were upset about it. And so from now on, I go through the office and warn people that the cannon's going to go off, which, fair enough. Right? Okay. Now, I have a magic trick for you, okay? I command you to bounce. I command you to not bounce. Bounce. Not bounce. Okay, I command you to become two different rubber balls, one that bounces and one that doesn't. Amazing! Woo! All right, thank you. Okay, okay, this one is made of rubber and it bounces. This one is made of rubber. Different kind of rubber though, yeah? Okay, this is made of a different kind of rubber. This one bounces back immediately. That's how you are elastic, right? Is that you deform and then boom, you bounce right off. Okay. This one has a time delay in it. The polymer is squishy, right? And so it's got a time delay, so it does reform back to its original shape, but it does it slowly, which isn't very good for bouncing, correct? Okay. So I'll pass these around, and the shiny one is the not bouncy one. You can sort of dig your finger into one and dig your finger into the other, and you can feel that one rebounds immediately, one doesn't rebound very quickly. Now, here is the question, and this is always a good question, is suppose you are a dictator. Okay, maybe you are Muammar Gaddafi, right? We shouldn't joke about this because, like, people are actually dying, so we'll just stop that. But anyway, suppose you are a ruthless dictator, and your question is, should you just shoot the people? Let's say you want to knock them down, right? Should you shoot